Hi, in this series, we will cover some of the buzzwords used recently in AI terms like LLM, AGI, RAG, embedding, vector database, fine tuning, and much more. But in this video specifically, we will be learning about these six. So, without any delay, let's begin. LLM stands for large language model. So, basically, what it does is there is a brain. Brain acts as a model, or you can say brain is equivalent to a model. It is trained on all of the stuff like photos, website, article, code, and everything. And when you ask something to it, like write a binary search code, it refers the book, or sometimes it already knows, so it responds to your screen. So whenever you hear cloud, opus 4.8, Gemini, llama, all these things are just model which are highly trained. And moving to AGI, AGI stands for Artificial General Intelligence. This one is heavily hyped, like you must have heard it a number of times now. So, what does AGI means? AGI would be more like human intelligence. It can learn anything, adapt to maybe a new problem, and it could have the ability to reason deeply. In the diagram, one central brain is connected to multiple skills, like just like a human can reason, plan, code, learn, all of this stuff. So this brain is connected to reasoning, planning, learning, perception, adaptation, etc. And you could summarize it as one intelligence doing everything. Example, we are telling AGI to build a startup. It could actually plan your product, marketing, hiring, everything. That is AGI for us. Then another hyped buzzword is retrieval augmented generation, also known as RAG. And you must not worry about the fancy name. The concept is very easy. Sometimes AI does not know the specific information. For example, your company's private document or your college attendance policy. So instead of guessing, AI first searches relevant document. And in the diagram, as you can see, user is asking a query from the LLM. The model is trying to get the answer on which it is already trained, but since it cannot find it, it is going to the another database or another place where your PDF is kept, and it then retrieve those information from that PDF or document, and then LLM reads those information and then it craft your answer. So the model isn't answering only from the memory. It is also checking your notes first. Think of it like an open book exam. So example could be, you are asking what is the leave policy of our company, and AI, instead of, like, it won't get information from the database, so it is searching the HR document first and then responding accordingly. So that is RAG for you. Another one is embedding. This is super important. Basically what happens is computer does not understand word like humans do. They understand mainly numbers. So embedding converts words into, you can say, number, and it could convert words or sentences into number. And in the diagram, like, text goes in to the embedding model, and what embedding model does, it processes it, and then at the end it returns some numeric value 0.21, 0.41, and that's typical vector embedding for you. For example, car and vehicle will be close, like they are interrelated, but car and pizza will be far. And that's how AI understand meaning, not just exact word. For example, good battery and excellent battery life are understood as similar. Then comes the vector database. A vector database, what it does is it stores the embedding. It is like a database for all your embeddings. Normal database searches exact matches, but vector database searches meaning. In the diagram, questions like become vectors, and vector database searches nearest vector, and the similar results could be returned. Yes, the result could be wrong also, but typically the similar results are responded by vector database. It cares more about how similar or how close I am to the response, and that makes AI search much smarter. Vector database are heavily used in rack system. Example, whenever you search for phone battery problem, and it can still find poor battery backup even though words are different. Alright, for this video, the last buzzword is fine tuning. Imagine you have a very smart student. You already know math, science, history, basically everything. That a student is like a base AI model which has the knowledge of everything. But now you want him to become an expert in one specific field, like in law, medicine. So what you do? You give him a specialized training only on medical or legal data. And this process of giving the specialized training is called fine tuning. If you look at the diagram on the left side, you have a pre-trained model and which is already smart, but then you feed it with domain specific data like medical record, legal document, and then after the degree of this model is completed, it become a fine-tuned model. So instead of teaching AI from zero, you are just refining it. Think of it like a school education is pre-training, but a medical college is like completely fine-tuning. In a specific domain, you are training it. So, for example, a normal LLM may know general health advice, but after fine-tuning on hospital data, it becomes much more at answering medical questions, and that's fine-tuning, taking a general AI and making it a specialist in its domain.